We're going to be doing today is going over these questions. I'm going to try to get through as many as I can, but hopefully after I do a couple of them, you'll understand the process. All right, so let me switch back over here. All right, so in this first question, it's asking if a car has 504,175 joules of kinetic energy and has a mass of 1,204 kilograms, what would the velocity have to be? So if I look at my equations, well, first off, let's write down what we know. So we have 504,175. That's joules, and that's going to be referring to the kinetic energy. And then it has a mass of 1,204 kilograms. So these are my knowns. And then I need to figure out what I need to find. And it's down just a little bit. All right. So it says, what would the velocity have to be? So I need to find velocity. And that's going to be in meters over seconds. So when we're given a problem like this, very first thing you do, you write down your knowns, write down your find, and then once you have figured that out, you need to try to determine which equation that you need to use. So I look at the find variable, what I'm looking for. So in this case, it's going to be V. And since I'm dealing with kinetic energy, I'm only going to be looking at this column here. These are all the equations for kinetic energy. And since I'm solving for V, I'll look for the one that's already solved for V. So that's that one. This guy here. Cool. So I just want to make a note that these two equations come from this equation. All I've done is I just solved it algebraically for you, so you don't have to do any of the algebra. You just have to figure out which equation to use. And in this assignment, you're going to only use these equations once. Okay, so once you've already used one, you can mark it out. So, the same thing goes for these. They come from this, and these two come from this one. I've just solved it algebraically. So, for my first question, because I think the order of the questions is flipped around for some of you guys, I'm solving for velocity first. So that is going to be this equation here. So the equation is going to be velocity equals 2 times the kinetic energy over the mass, and that's all under the square root. Now, when you plug this into Desmos, I want to make it explicitly clear that this is not equal to this. Now, when you put it into Desmos, you need to make sure that it visibly looks the same as that. Because if it doesn't, then you're not going to get the correct answer. Okay. So, do I have kinetic energy? Yes, I do. That's going to be right here. And do I have mass? Yep. So I'm allowed to plug in. So I have 2, and then I put parentheses where I'm plugging in, just to make sure I do the math correctly. So 504,175, 1204. Okay. Now what I'm going to do Wendy is here. Let me get her. Alright, did anybody else come in? Natalie's here. There's Chris. Alright, Jacob, come on. Nope. Nathan, Sean, Trevor. Okay. So that's it. Alright. Let's switch over here. Okay, calculator. Alright. So when I switch to here, when I'm trying to put my formula in, so just to remind you, this is what I'm trying to put in my calculator. This right here. Now, in order to put that in, I recommend doing this. So 2 times 504,175. Now, do not put in commas. The commas will mess it up. So if you do a close bracket, it'll automatically put an open bracket or open parentheses over here. And then 1204. And then in order to get it underneath the radical, I really wish Desmos had like a fraction symbol, but they don't. So then if you do that, put the radical in there, go behind the radical. If I select this, I cut it, and I paste it in, that's my answer. Okay, so just to make sure, this looks exactly like this. So the 2 times, like the only difference is the parentheses in here, and I can actually get rid of that. That was only to get both of these, get that on top of the fraction bar, but they're not necessary. So hopefully everybody sees that this is the same thing as that. Cool. So I get black. Get approximately 28.939, and the question says round to 1 decimal point. Okay, so since this is 939, if I'm rounding to 1 decimal point, that's going to be this guy. This is the guy that I'm rounding. So I look at the one that's to the right of that, and if this is a 5 or above, so 5, 6, 7, 8, 9, then I'm going to round up, and if it's a 4 or below, I'm going to round down. So in this case, it is a 3, so I'm going to round down, so this will end up being approximately 28.9. And that's what I'm going to put in as my answer. $28.9. Cool. All right. So now for the second question. Or is there any? Oh, and this is going to be meters per second, but you guys don't need the units in it. Yes, Jaylee, you can go ahead. Hope you feel better. This this is being recorded on YouTube, so if you need to go back and watch it, you can. Cool. All right. Question número dos. All right. So we have now used this equation, so we cannot use it again. So that's gone. All right. And if you'll notice, all the questions with the little car that I made, those ones are going to be dealing with kinetic energy. Okay. So write down my knowns, write down my find. So I've got 2 knowns, I'm going to have 1 find. Alright, so in this question it says if a car with a mass of 506 kilograms, so I have mass equals to 506 kilograms. And since I'm writing on the screen, guys, if you see somebody who comes in later, please let me know. I see Jacob came in. There's Nathaniel. Okay. So Sean, Trevor, come on. Are the only people that I'm missing. Alright. Okay. So we have the mass, and then velocity is 28 meters per second. So velocity is 28 meters over seconds. And then it's asking us to find kinetic energy. Alright, so that's going to be a capital K. And I put the little bars on it to represent that it's kinetic energy, so I don't know what that is. And that is going to be, now if you read the question, it says your answer should be in units of kilojoules. So kind of like kilograms and grams. A kilogram is 1,000 grams, so therefore a kilojoule is 1,000 joules. So the answer that I'm going to get when I plug it into Desmos is going to be in units of joules. So in order to get units of kilojoules, I just have to divide that answer that I get in Desmos by 1,000. Okay? So, since I'm still dealing with kinetic energy, I have to find the equation. So the question's asking to solve for kinetic energy, and I'm given the mass and I'm given the velocity. So let's go back up. So I'm still dealing with this column, and I'm solving for K, kinetic energy. So that's going to be this equation here. So 1/2 mv squared. So my equation I'm given mass and I'm given velocity. I'm sorry for not being consistent, like whether I'm going below or to the side. Hopefully you guys can track that. Alright, so mass and velocity are my variables that I'm plugging in for. So 506 for the mass, and then velocity is 28. So then all I have to do is to plug this into Desmos. Let's switch back over here. So it's going to be 1/2, or you can do 0.5 times 506. Now remember, my questions are going to be different values than yours. So 28, close parentheses. I'm going to put a multiplication there, and then I'm going to square it. Okay, so like I mentioned before, this is given to in units of joules. So just for the sake of clarity, what I'm going to do is I'm going to do 1/2. There we go. So this is the 1/2 m and then v squared. So this is in units of joules. I want it in kilojoules. So what I'm going to do is I'm going to take this number, copy and paste, and then divide by 1,000. Cool. So now this is the units of kilojoules. So I'm going to switch back over here in just a second. So 198,352. That's going to be joules. So 198.352 kilojoules. Okay. So this was the answer that we got from Desmos, from that equation, and that's in units of joules. And then, so my decimal point was right here, and in order to convert it into kilojoules, I just move it 1, 2, 3 times to the left, and that's where I get my decimal point right there. Alright. So, let's see what the question is asking when it comes to rounding. Whoops. So it says round your answer to 1 decimal point. All right. So if I'm rounding to 1 decimal point, this is the one that I'm looking at to round. This is the one that I'm going to be modifying. So I look to the one that's to the right. If it's 5 or above, I round up. So that means that this value here is going to go up by an increment of 1. So instead of a 198.3, it's going to be approximately, and I'm doing the approximately because I am rounding. I didn't put approximating here because this is the exact number, because all I did was I just changed units, and I didn't do any rounding going from this step to this step. So I get approximately 198.4 kilojoules. So that's what I'm going to be putting in my answer. So 198.4. And remember, don't put the units in. All right. So I'm going to skip this one because I do want to do one where, so the gravitational should be pretty easy. Those equations are pretty straightforward. And so we've already used this equation. So these ones you should be able to do. There's no radicals or anything like that, no squares. But I do want to focus on the elastic potential one. So I'm going to jump down to the ones dealing with the displacement. I want to do one with the spring constant. Yeah. All right. So in this question, and in my version of the quiz, this is question number 7. So I have a spring that has been compressed by a distance of 0.4 meters. All right, so this is for 7. All right. So it's been compressed by a distance of 0.4 meters and has an elastic potential energy of 76 joules. What is the value of the spring constant in newtons over meter? And I round to the nearest whole number. So if I look at my equation, what I want to emphasize is that, or just as a reminder, this is the spring constant. And this is the displacement. So is the displacement of the spring from its rest length. So it can be compressed or it can be stretched. It doesn't matter if it's positive or negative because when you square it, that'll just come out to be positive. But in this example, it's asking us to find the spring constant. Okay. So since we're dealing with elastic potential energy, we're going to be using this equation here. So let us write down our knowns. So I do know the displacement of the spring, so that's going to be my delta x. Remember, the delta just means change, so my change in position is going to be 0.4 meters. And then my U elastic was 76 joules, just to make sure. So 0.4, 76, and then I'm trying to find the spring constant. So that is a lowercase k, and I don't know what that is, so that's going to be in newtons over meter. And so the spring constant is going to be 2 times U elastic over delta x squared. And just to make sure I did it right, yep, 2 times U elastic over delta x squared. Okay. Now since I know both of those, all I have to do is plug in. So 2, so So it's the same process as before. So U elastic in this case is 76 and 0.4. And then get rid of that, get rid of that. Switch back over here. So I'm going to have 2 times 76. Now I want to show you, if I don't put the parentheses, watch what happens. When I do the division, it only goes under the 76. I don't want that. So what I'm going to do is I'm going to put a closed parentheses, and again that automatically puts the open one on the end. And then I'm going to do the division here, and then open parentheses 0.4, close parentheses, and then I will square it. So I get 950. So if I switch back over here, so my spring constant, and since it's exactly 950, I do an equals. So my spring constant, make sure it's lowercase, is 950 newtons over meter. And again, when we plug this in, we do not put the units, so round to the nearest whole number. Luckily it's already a whole number, so 950, and that should be it. Okay, so hopefully these examples kind of clear up any confusion that you guys may have had, and for those individuals from other classes that are watching this video, if you have any other questions about this, please reach out to me. And let's see, do we have enough time? Yeah, we got enough time. All right, so I want to do one with gravitational. How about that? So let's switch back over here. So the gravitational potential energy, I'll just do one more. Cool. All right. Then. Where are you glitching out? So this is number 5. Knowns. Find. Okay. Alright, so I go back to my question. If an object with a gravitational potential energy of 11,822 joules and has a mass of 9 kilograms, what is the height above the ground? All right, 11,822. So I have ugrav 11,822 joules and has a mass of 9 kilograms. And it's asking for the height in meters. So if I go up, this is dealing with gravitational potential, so this could be the middle column, and I want to find one that starts with H. Go all the way up, so this is the column I'm looking at. Starts with H, so that's going to be this bad boy right here. So ugrav divided by G times M. Okay, so a couple of the sharp-eyed individuals that are watching might notice that I don't have a value for G. Okay, it's not in my knowns. So if I look back at my problem, you'll see that it says, remember that G is equal to 10 meters over second squared. So in my class, we use 10 to keep the math easy. It's technically 9.81, but in order just to keep the math simple, we're going to use 10. So I can actually put that in down here with my knowns. So 10 meters over second squared. Okay, so now all I have to do is plug in what I know. So ugrav, it's going to be 11,822. Got 10 for G, and then I've got 9 for the mass. And then when I plug this into Desmos, I get 11,822. Now remember, don't put the commas into Desmos because it will mess it up. And then in this case, I don't need the parentheses because there's only one thing in the numerator. So I do 10 times 9, and I get approximately 131.355. This is going to be in meters. So switch back here, and it says round to the nearest whole number. So if I look at this, the nearest whole number would be this value here. So I look to the left of it. This is 4 or below, so I'm going to round down. So I get approximately 131 meters for the height. Cool. All right. Switch back over here. All right, so that's going to end the live stream.